Hello, everybody. Today's topic 5.2.3. How else can I write the equation? Since the learning target for today is today I'll be able to write arithmetic sequences from recursive equations and convert between explicit and recursive equations to write those sequences. So, in this chapter, you've been writing equations for arithmetic sequences. Today, you will investigate recursive sequences. A term in a recursive sequence depends on the terms before it. So consider the following sequence: -8, -2, 4, and 10. Part A, what are the two ways that you could calculate the 10th term of the sequence? And what is a 10th term? So the method one is what you guys have been learning before, which is I can use an explicit equation. And to do that, we have to figure out what's t of 0, right? Our 0th term, not our first term. Remember, this is our first term. And then we also have to find the common difference. So let's start off with the common difference. Here we go up, we go from -8 to -2, from -2 to +4, and then from 4 to 10. If you were to subtract -8 from -2, then you would find the common difference, which in this case is +6. So that means we're adding 6. So here, +6, and then our initial value, our 0 term, right, would be we go back 6 from -8, and that would give us -14. So our explicit equation would be t of n equals 6 times n minus 14. The second method we can actually do is I can continue the sequence until I reach the 10th term. So right now we have 4 terms, right? If I keep adding 6, I'm going to have 16, and then I add 6, 22, 28, and so forth. So I can also figure it out over here. T of 10 equals 6 times 10 minus 14, which is 60 minus 14, which would be +46. Part B says if you've not done so already, write an equation that lets you calculate the value of any term T of n. So here we know T of 0 because we found it already. This is our 0th term, would be -14. And then again, our common difference, we already found it, is +6. And the equation would be T of n equals, like we said before, 6 times n minus 14. So this kind of equation is called an explicit equation, which means that it is clearly defined. This equation can determine any term in the sequence. So the next term after T of n is called T of n plus 1. For example, if we know T of 3, then the next term would be T of 3 plus 1, or just T of 4. If we know one term in the sequence, we can use the common difference to determine the next term. So for -8, -2, 4, 10, the common difference is +6. To help write an equation to determine the value of T of n plus 1, if you know what T of n is, we can use the following table. So the term number, in this case, is the term is T of n. So this would be that would be the first term, which in this case happens to be -8. And then that would be T of 1. And then using the common difference, the next term would be T of n plus 1, or 1 plus 1 in this case. Sorry. So 1 plus 1, which would be just T of 2, which you guys already know is -2. Same thing here. We're going to add 2, or n plus 1. Oh, this is where I started with the n. Sorry about that. It should be n plus 1, which is T of 2, and then this would be n. And then n plus 2, and so forth, because we started with n is equal to 2. So this is the third term happens to be +4. The fourth term happens to be 10, and then I add 6 to that, I get 16, and that would be T of n plus 3. If we know any value, t of n, we can calculate the next term by subtracting, right? So t of n plus 1, the common difference. So the equation t of n plus 1, here we would say it's t of n and then plus 6. So an equation that depends on knowing the previous term, it's called a recursive equation. The equation uses the common difference as it generates terms in the sequence and any nth term of the sequence.